Hi there, it's Sam from the shed here. You can see my shed, loads of components. Today I am circuit bending an upside down Casio SK-1, the little keyboard with the sampler, which is pretty amazing. And this video is about how to make the pitch mod. Basically, if you want to change the clock speed of the Casio, of this processor, you can do it, and that affects the pitch, of course. And how to do it is like using an external chip, which is an LTC 1799. Right, I'll just show you here on the board what I've done to achieve this, so that you can do it yourself in case you want to circuit bend one of these. So I was looking for points where on the board that would give me 5 volts, because this chip operates on 5 volts. And I mean, you can use the voltage regulator. For example, like this chip, I believe like that it runs on 5 volts anyway. This one gives 5.2, which is close enough to run this one. And so I wired this weird red and gray wire, and this is gonna be my positive power supply for this chip. Then here, this is a ground point. So these two, they're going to the breadboard. Yeah, breadboard, whatever. Then, so I didn't show you because like now it's all screwed in, but anyway, underneath here there is a coil which acts in a circuit as the clock for the Casio, and so for the processor from the main chip. And what you do here is to, it didn't come very neat, but you can use like a screwdriver or a little knife, or even better, a drill bit, and cut this trace here. As you can see, like here, basically there used to be a trace which I cut with my screwdriver, so that I interrupt the contact between these two solder points. Then you solder 2 wires. In this case, like I have a green one and a blue one. With the green one, that is gonna be the common, let's call it common for now, and the blue one is gonna serves me to connect the keyboard using the original clock mode. So whenever you turn on the modified or circuit bent Casio keyboard, you want to connect it with the original coil, so with the original clock, otherwise it doesn't start. Now let me plug the power supply at the back here. I mean, it should be better to do this with batteries, but I didn't have any lying around, so I'm using the power supply, which also has small voltages. So now the keyboard is operating. You see, like the green wire and the blue wire are connected, so it's like as if the trace was never cut. Now, as we say, we use the green as common, so I disconnect the blue and connect it to this other, sorry that is a bit wobbly the video, but I have just one hand. So I connect this crocodile clip to this the green one to the yellow one, that goes here on pin number 6 of the LTC 1799, and which is the output of the chip, so basically is the clock output. Then you have the positive power supply, which is the 5 volts that goes to pin 1, and then you have the negative one, so the ground that goes to pin 2, and between pin 1 and 2 there is a 0.1 microfarad or 100 nanofarad between, as I say, pin 1 and 2. So this is my circuit. Like, it's a bit different than the ones you find online, because I like to have more controls over things. So you have like this jumper wire, like goes from pin 1 on the breadboard to a trim pot, which is a 10K, though it's not connected properly. So this one is another one that I was playing with. So this is the original one, I think. So I found a sweet spot. Basically, this will help you set up the pitch bend in the best way you like, but also like you will have to set it up in a way that when you turn the pot, the main pot, as we will see, which is this, the pitch pot, all the way up, this buffer resistor, variable resistor, will help you so that the keyboard doesn't crash. Because if the resistance is too low, basically it will crash the keyboard, because like the clock rate would be too high and the keyboard wouldn't be able to handle it, the processor, and it will crash. Right, so this one is wired, and then I wired a 4.7 kilo ohms potentiometer here, which will act as a fine-tuning basically pot. Then from here, this yellow wire goes here, connected to this light dependent resistance. Then this light dependent resistance is wired to this green wire that goes to lug 2, but you can connect lug 1 and 2 together, of this pot, which is gonna be the main pitch potentiometer, and the gray one will end up on pin number 3. As you can see, there is a jumper wire between pin 2 and pin 4. If you disconnect this, so basically if you disconnect the ground from pin 4, the pitch will go very low. So when I will actually put like switches and I will effectively put the circuit on the Casio, I will put push button in between and maybe a switch as well, so that I can lock it in, and that will give me access to very low pitch sounds, which I particularly like anyway. What else? So we said that the pin number 6 here, the yellow one, is the output, and when you build it, like, you can probably wire a switch between the green wire, the blue wire, and the output of the LTC, putting this one in the center. So let's see if I have well, I don't have a proper switch. This is like an old one, but you can see you can put the let's look at, here it is. So let's say that you would put the green wire on number 2, the blue wire on number 1, and the yellow wire, so the output of the LTC 1719, on number 3, so that flipping the switch, you will have access to the original clock or the LTC clock. Right, so let's see what happened when I turn on the keyboard. Now, so now I should play normally. Let's see if I can access backwards like a demo mode. Is there a demo? Oh, here we go. Very happy song. Oh, it's not the demo, like it just plays the chords. Now we're gonna disconnect. You can see that if I touch here, it goes down in pitch. Now I'll disconnect this, it will go crazy, and I connect it to the LTC clock. It's already low, as you can see. So now this is connected to the LDR. So let's put it up. So this is fine tuning, so it changes the pitch but not too much, so you can do like fine adjustments. And this is quite drastic. Right, if you want to not use the LDR, the light dependent resistance, so like to use it as a theremin, let's say, if you want to avoid that, you simply connect this one straight to the green one, right? You can see now it doesn't, this one is disabled. Basically you can do that simply with a single pole double throw on switch, which switches basically moves this wire, sorry, this yellow wire, either here or there, engaging the light dependent resistance. As you can see, like, it's gonna go very nice. So let's pull like a high pitch, and I'll show you what happens if, right, as I say, like there is this wire here, the blue one that I'm touching, that connects, oh sorry, this one here actually, that connects pin number 2 to pin number 4. Let's see what happens if I disengage this one. The pitch should drop very low, and there you go. Which is quite like, you know, doomy sounds, like very nasty and distorted. And you can put like a push button to act as a temporary switch, which will do like, or you could even automate it. It's quite cool. And if I remember well, if you connect this to the power, so to pin number 1, it's even lower. So it's basically, now the speaker is basically farting. Let's see if I turn on. Yeah, can't do it. So let's put it back to ground now. And then let me just show what I've done. So here on the board, you can see this is the main processor, is the OKI M6283, which basically is the heart of the keyboard. And here you can see connected, there are 6 rows of pins, and there are like 3 chips of the ROM, and these are the points where you can do all the patch basically all the glitches in the machine, but we'll come to that later. Right, let's have a look. Here you can find that there is this trim pot, which actually is accessible via the back case of the keyboard with a screwdriver, and you can change the tune of the keyboard basically, if you can see. So basically here you can tap in for the ground, and here where I marked there, you know, let's see if you can, yeah, no, that's better. You can tap in for 5 volts. Then next to this trim pot there are all these pins together, and this is where the coil is, and you cut the trace there where it is, you can see it, and then you connect the 2 wires. So I made a schematics here that maybe is clearer than my words. So what you have here is that like pin 1 is connected to 5 volts, then you have a capacitor between pin 1 and 2, which is the ground, and I believe that's a decoupling capacitor, so this one goes to the ground. Then from pin 1 you go down, and you have like this trim pot here, which is a 10 kilo ohms trim pot, which is a buffer. Basically it prevents the keyboard from crashing down when you pull the clock too fast. Then you have a 4.7 or 5 kilo ohms potentiometer, which is the pitch fine pot, as I called it. So with this you can do fine tuning of the pitch. Then here it gets messier because it's where we introduce the LDR. I like to have like this feature on the keyboard, that a circuit band. I don't always put it there, but like it's quite cool to have basically gesture control over your sound. I like that. And so basically you can access that with the switch. The main bit is this. So this is the pitch core spot. The first and second lug are connected together, and these go to the common pin of a switch. Then depending if it's connected on 1 on the first position, basically you are ignoring, you're not including the light dependent resistance in the circuit. While if the common is connected to pin number 2, which is the other external pin of the switch, the LDR is part of the circuit. And so basically from the pitch fine it goes to the LDR, and then from the LDR it goes to the main course potentiometer. If not, it just goes via this route 1 to C to the pot, and then the potentiometer third lug is connected back to the third pin of the LTC 1799 chip. Then for the low pitch drop, as a preset, you have like pin number 2 connected to pin number 4, so you can use a normally closed push button, right? So that the circuit is always closed between pin number 2 and pin number 4, and when you press the push button, you open the circuit rather than closing it, although the symbol is still the same from what I've drawn here. But anyway, when you press the button, you can engage it with a switch. You disconnect pin number 2 and pin number 4, and that drops the pitch, so basically it keeps the clock frequency lower, and it generates all those weird sounds that are really cool. 5 is not connected, and then 6 is your output. So this is the output of this clock that goes to one of the pins of the clock switch. I call it clock switch. So you have like this goes to one of the external pins. Then on the central pin you have the green wire, which is this bit here, which we can call it the common. Really, like, it doesn't matter, you can connect either one. And then you have the blue one, which is this one. So basically, when the green is connected to blue, the keyboard works in factory settings, so with the clock dictated by the coil. And when you move the switch, the green connects to the output of the LTC, and there you have access to a whole range of pitches, which is the funniest bit. So this is the basic setup. One thing that I like to do, and that I will do for this Casio in particular, you can break the circuit here, and here where you have this 100k potentiometer, which is your main pitch potentiometer, you can put like double pole, double throw 2PDT, I think 2PDT, yeah, switch, which allow you to switch between this and two other pins. Let's say we call this pitch A and pitch B, and you can have like a switch which is made like this. It has like 1, 2, 3, 4, 5 pins, so it's a double throw, double pole, double throw. So double throw means that it has two positions. So the common line, which is this common, is connected to either these two sides. So this is connected to this, and this is connected to this, or in the other position, this is connected to this, and this is connected to this. So if this is the common pitch, let's say that goes between this point A and this point B, let's say that here the wires, we disconnect them from the pot, and we name this A and B. Then A and B, so the wire, can be connected to pot lug 2, pot lug 3 of this potentiometer, or they can be connected to X and Y, which could be, for example, the output in terms of resistance of a sequencer, and that's what I will do. So the sequencer that I will build will be a sequencer that doesn't output voltages but outputs resistances, and this is done using an encoder decoder IC, which is the, I think is the CD4051 4051, and here is where I keep all my CMOS chips, which are logic chips. And yeah, so it's the 4051, which allow you to route. Is basically, you can route like the signal however you want, and in this case I'll be routing it to different potentiometers. In this way, like basically I can route resistances rather than voltages, which is pretty handy for circuit band toys, because this way you can create a very nice pitch control using this little LTC 1799. I hope this helps. If you have any questions, just hit me and I will try to answer and be as helpful as I can.